Hello, viewers. In today's class, we are going to discuss one important integral from definite integrals, right? And here we have to solve this integral that is from -1 to 0. And here we have mod of x plus mod of 1 minus x, right? So here we have an integral which involves the absolute value function, right? So here for the integrand, we have the sum of two mod functions, right? So let us take this integral as I, and let us take this integrand as the function f of x, that is equal to mod of x plus mod of 1 minus x, right? And here the limits of integration are from -1 to 0. It implies that x belongs to this interval, that is -1 to 0, right? So now here we have two methods to solve this integral, right? So the first one is to evaluate the two separate integrals. That is, we can also write this integral as I is equal to -1 to 0 and mod of x dx, and then we have -1 to 0 and mod of 1 minus x dx, right? So here we can express this integral as a sum of two integrals, right? And we can separately solve these two integrals to get the values of this integral I, right? But here we'll not follow this method, right? So what we will do, we'll try to redefine this function f of x, which is the sum of two mod functions in the interval that is -1 to 0, right? So let us see how we can first redefine this function f of x in the interval -1 to 0. So here we'll make use of the definition of mod function, right? So the absolute value function is defined like this. Suppose we have mod of p, right? So mod of p can be defined as positive p whenever p is greater than 0, and mod of p is equal to 0 whenever p is equal to 0, and mod of p can be written as negative of p whenever p is less than 0, right? So this is the basis of solving this integral, right? So here let us first take mod of x, right? So here mod of x is equal to negative of x whenever x is less than 0. So here we have expressed mod of x as negative of x whenever x is less than 0 by using this definition, right? So here our x, it belongs to this interval, that is x belongs to the interval -1 to 0, and we can easily see that all the x which belongs to -1 to 0, all the x are less than 0, right? So mod of x is equal to negative of x, right? Because here our limits of integration are from -1 to 0, right? So what we will do, we'll replace this mod of x by negative x when x belongs to this interval -1 to 0. Now let us take mod of 1 minus x, right? So mod of 1 minus x can be written as positive 1 minus x whenever 1 minus x is greater than 0, right? Now in this case, we have used this definition, that is mod of p is equal to positive p whenever p is greater than 0, right? So here we are writing mod of 1 minus x as positive 1 minus x whenever 1 minus x is greater than 0. So if we now solve this inequality, then we'll get 1 is greater than x, right? Or we can also say that x is less than 1, right? And obviously all the x which belongs to this interval -1 to 0, all the x are obviously less than 1, right? So we have to take mod of 1 minus x as positive 1 minus x, right? So here we cannot take mod of 1 minus x is equal to a negative of 1 minus x, right? So if we take mod of 1 minus x is equal to negative of 1 minus x, it implies that 1 minus x should be less than 0, right? And when we solve this inequality, 1 minus x less than 0, then we should get 1 is less than x, or x is greater than 1, right? And in our interval, when x belongs to minus 1 comma 0, then the all the x are not greater than 1, right? So here we cannot take this definition of mod of 1 minus x, right? So now mod of x is equal to negative x whenever x is less than 0, because in this interval all the x are less than 0, right? And similarly mod of 1 minus x can be taken as positive 1 minus x when x is less than 1, and all the x which belongs to this interval are less than 1, right? So now we can define this f of x as negative x. So mod of x is replaced by negative x, and mod of 1 minus x is replaced by positive 1 minus x, right? So here we'll write plus 1 minus x. So now we can simplify it. So we have minus 2x plus 1, or we can write 1 minus 2x, right? When x belongs to this interval, that is minus 1 comma 0. So whenever we come across with integrals involving these type of mod functions, we have to take care of the mod functions, and we have to be very careful which part of the definition of mod function is to be taken, right? And here we also take care of the lower limit and the upper limit. So now f of x is equal to 1 minus 2x when x belongs to minus 1 comma 0. So now we can write this integral I as minus 1 to 0, and for this function we can write f of x dx, and now f of x can be replaced by 1 minus 2x, right? So here we have 1 minus 2x and dx. Now we can easily uh, write the integrals of these two terms. So here the integral of 1 dx is simply x, and the integral of x is x square over 2, and the limits are from minus 1 to 0. And now we have here 2 and 2 get cancelled, so we have x minus x square, and this is minus 1 to 0. And now we can substitute the limits. So when we take x is equal to 0 here, we'll get 0 minus 0 square, and when we take minus 1, then we have here minus 1, and here we have minus 1 square, right? So this term is entirely 0. So we have 0, and here we have minus 1, here we have minus 1 square is plus 1. So we have minus 1, so this is minus 2, minus 1 is minus 2, so this is plus 2, right? So the value of this integral I is equal to 2, right? So viewers, this is how by making use of the concept of mod function, we can evaluate these type of integrals.